Hello! In this video, we will learn about entity-seeking queries. An entity-seeking query is basically a search query where the main purpose of the searcher is to find a specific entity. That entity could be a person, a place, an organization, or a concept. So in these queries, the user is looking for a specific item within a broad category. It has some key points. Firstly, these queries focus on a specific entity. Secondly, context is essential in these queries. For example, let's say a person searches, who is the hero in Harry Potter? Or which actor played the hero in the Harry Potter movie? Or who is the CEO of Tesla? The answer to these queries will be a single word, such as Elon Musk, the CEO of Tesla, or the actor who plays the hero in Harry Potter. Now I will search here, CEO of Tesla. You can see it appearing below and also prominently displayed here. There is a patent for this entire process. When a query comes, it first goes into the query mapper. We will break down all these elements later. After that, it goes into the semantic dependency tree. If you want to understand the semantic dependency tree, there is a dedicated lecture on it that you can watch. Then it goes to the entity type identifier. From there, the entity type is determined. After that, it passes through 2 or 3 more processes: subquery resolver and query responder. Finally, it retrieves the necessary information from storage and provides the response at the end. Let's understand all the points. First, the query mapper basically converts the query into a semantic dependency tree. Next, the entity type identifier determines what the user wants to find in the query: a person, a place, a restaurant, or something else. Following that, the entity identifier looks at the data and calculates the relevant score to pick the correct entity. Then comes the subquery resolver, whose job is to break down the query and then provide the answer. After that is the query responder. This is the final step, and it provides the response to your query. Now, let's say someone searches, call the Chinese restaurant on Piccadilly Street 15. The query mapper will create a map of the entire query. Then the entity type identifier will see that this is about a Chinese restaurant. Next, the entity identifier will look in the database to see which restaurant has the highest relevant score at that exact location. If needed to understand the query, the subquery resolver is used. Finally, the query responder shows the answer, which is the Chinese establishment. When a query is searched, Google quickly has to determine whether it is an entity-seeking query or a non-entity-seeking query. As mentioned earlier, an entity-seeking query involves a specific object, place, person, and so on. A non-entity-seeking query is where a user wants to find information, data, weather, or similar things. If the query is find a hotel that looks like a ship's sail, the system will check and tell you through the whole process that it is the Burj Al Arab Jumeirah. Now, what does a non-entity-seeking query look like? What is the weather today? In this case, the weather information will be provided, today's temperature, if it will be sunny or rainy, and so on. When a query is detected as entity-seeking, the entity type identifier first checks what the person is asking for: a hotel, a restaurant, a movie, a person, or something else. Then it checks whether the user needs a single entity or multiple entities. As we saw before, the identifier allows multiple entities to be displayed. Next is finding the most relevant entities. The database will check web resources, user history, and location data. By looking at all these factors, the most relevant entities will be shown as the answer to the user. Now, let's say a person searches, find an Italian restaurant near me. The system might respond, can you give me more details, or show an error that the exact entity was not found. When the user responds with further details, the system can correctly provide the answer. Now, handling subqueries. A person searches the query, call the hotel that looks like a sail. What is the subquery here? A hotel that looks like a ship's sail. The subquery answer will be Burj Al Arab Jumeirah. The system will integrate the answer part into the original query. It will take call the answer and integrate the answer, resulting in call the Burj Al Arab Jumeirah. Then the system will execute it. The system also basically searches the user's activities. For instance, if 60% of a user's previous queries were entity seeking, the system will focus more on the new queries, checking whether the person searching requires an entity. What is the benefit of this? Speed and user satisfaction. These systems are also used in chatbots and similar platforms. The user benefits by getting the answer quickly. Just like when we searched for the CEO, there are many queries like Pakistan, Islamabad, and others that require a single answer, which Google has already stored. Efficient entity identification is another benefit, as the entity can be easily detected. Furthermore, queries are mapped using the semantic dependency tree so that the queries can be easily understood. This is our semantic dependency tree. Here, call has been broken down and separated, and Chinese restaurant has been separated. This forms a structure like branches where it continues to break down further. In this query, the root is the Chinese restaurant and the rest are its nodes. The entity with the highest relevant score is picked to provide the answer. Now, let's say multiple entities have a very high relevance score and meet the threshold. Then multiple entities are shown. Furthermore, this entire system retrieves data from multiple sources, web resources like articles, user location, where the user often goes, user activity, what searches they have performed before, and geographical data such as local search data.